Continue working on your scene, or open the file environmentreflections.max that you downloaded for this tutorial. At this time, the reflections are completely incorrect, as they are just using a projection of the background image from the camera point of view. In fact, to see the problem better, double-click the booth and hide it. Double-clicking the booth ensures you select all objects, including the booth itself and its children objects. Instead, create a teapot with 8 segments. It's a simple enough object that makes the problem easier to study. In the material editor, create a new Arc and Design material and base it on a chrome metal preset. As far as reflections go, a chrome finish is as good as it gets. Apply to the teapot and render the scene. This is certainly not what chrome should look like. It appears reflective, but it's reflecting the wrong environment. It's reflecting what is effectively in front of the camera, whereas it should be reflecting the opposite viewpoint, what is behind the camera. You have a few options to proceed, but all involve taking a picture opposite the one you are using as a background. Ideally, the best environments are based on 360-degree panoramas. These require some work to get done properly, and even some specific hardware to take the right pictures, and special software to process them. This is not what we are using here, although I reserve that idea for a future tutorial. The next best thing would be a 180-degree or even a 360-degree cylindrical panorama. This is easier to achieve. Many cameras on the market today, and even some smartphones, allow you to take such panoramas by sweeping the camera across a landscape. If you don't have such a camera, you can still take 3 or 4 vertical pictures and merge them together in Photoshop. Photoshop has a tool under File, Automate, Photo Merge that can take overlapping pictures and merge them together. Ultimately, you can take a single picture opposite the one you're using as a background, but that approach would require a bit more processing. Whichever method you choose, you need to use that opposite picture as a reflection map, otherwise the results are quite unsatisfactory. Take a look at the Chrome Arc and Design material. It has an environment slot. Load up the reverse JPEG image and wire it to the environment map channel. Double-click the bitmap node and set it to Environment Screen and render again. Well, it's a little bit better, but not quite great yet. At least, the transparent effect has gone away, since the image used as a backplate is no longer used for reflections. However, the image that is used is still being projected flat on the teapot. You would want it to wrap around somehow. The image used at this time is a typical 4x3 image, much as you would get taking a picture from a point-and-shoot camera. Ideally, you would want to turn that rectangular picture into a chrome ball or a probe picture, such as seen here. There are tools that enable you to do this, but you can simply use a feature built into 3ds Max. From the Mental Ray Maps list, drag in an Environment Probe Chrome Ball map. Use it as an in-between to wire the image to the environment channel. You also need to switch back the bitmap to texture mode. Render again. This is much better, although the ground reflections still seem a bit odd. This is because the ground also needs to account for reflection coming from all around. At this time, it's only taking into account the image used as a background for render. In fact, the approach you tried, where you specified a different reflection map at the material level, is not an optimum solution. You would need to repeat it to every shiny material you define in the scene. A much better approach is to work at a global level, namely telling Mental Ray to use one image for a background and another for scene reflections. For that, you use the Environment Background Switcher map. First, get rid of the maps you use for the chrome material. This means the teapot would render transparent again. Go back to the first viewer window in the material editor and get rid of every node except the Mental Ray Matte Shadow Reflections material. Next, add an Environment Background Switcher map to the viewer. This is a special map that lets you specify different images for background and reflections in a single scene. Open the Environment dialog and replace the old environment map with the new switcher map. Make sure you use Instance to keep a live link between this map and the environment background. Next, bring back the background JPEG image you used earlier. Set it to Environment Screen and wire it to the background channel. This will act as a render backplate as it did earlier. Next, import the reversed JPEG image meant to be used for reflections. Add an Environment Probe Chrome ball as you did earlier, and wire that to the Environment Reflections channel. This will be used for global reflections. Finally, wire the switcher to the camera mapped background of the matte shadow material. Render the scene. This ought to look much better than it did before. Actually, because reflections are mirrored, you typically want to flip the reflection image horizontally. This can be done in any paint application, or simply by setting the image's U tiling to -1. As mentioned earlier, using cylindrical or spherical maps typically works even better. In this case, bring in the file named Cylinder Environment JPEG into the material editor. Set the image as an environment cylindrical environment. Set the tiling to -1 and wire it to be used for reflections, replacing the chrome ball you used earlier. This looks much better. One final adjustment, set the U offset to -0.3 for proper placement of the reflection image. Now that you have the background and reflection images in place, you can get rid of the teapot and bring back your kiosk design. Go back to the second viewer window in the material editor and get rid of the chrome material. Render the scene. The reflections certainly seem appropriate and any transparency tendency has completely gone away. Also, the reflections are good and true, as you can see the reflection of the counter in the red column. The final result is a bit too bluish, though, affecting the material's red color. This is due to the Mental Ray sky that affects global lighting based on the time of day. If you need better control over global illumination colors, you can revert back to a skylight system. You may also want to decrease the multiplier value so that it's not overly bright. With a white sky color, the red should be quite a bit more saturated. One final word, the background switcher does not display properly in the viewport. If you need to see the background in the viewport, you need to load it as a bitmap file instead of an environment map. In the next movie, you finalize the work on the materials.